Imagine tiny objects zooming around Earth, thousands of miles per hour faster than a speeding bullet. Some are as big as a bus, others are mere flakes of paint. All of them are potential threats to the valuable satellites we relying on every day for communication, navigation, and even weather forecasts. How do we keep tabs on this cosmic clutter and protect our vital spacecraft? We track different sizes of space junk by employing a range of specialized tools and techniques, with the specific method depending primarily on the object's size and its orbital altitude. Essentially, larger pieces of debris are monitored using powerful ground-based radar systems, while smaller fragments are often observed by optical telescopes, and the very smallest are typically accounted for through statistical modeling rather than individual tracking. The reason we need different approaches is rooted in physics and the practical limitations of detection technology. Larger debris, generally defined as 10 centimeters or larger, reflects radar signals effectively, allowing ground-based radar systems, like those operated by the United States Space Force's Space Surveillance Network, to precisely pinpoint their location and predict their future paths. However, as objects get smaller, their radar signature diminishes, making them harder to detect consistently. For objects between 1 and 10 centimeters, which are still large enough to cause catastrophic damage, optical telescopes become more useful, especially during twilight hours when the debris can reflect sunlight against a dark sky. The smallest pieces, from a millimeter up to 1 centimeter, are virtually impossible to track individually with current technology, so their populations are estimated through statistical models derived from impacts on returning spacecraft and ground-based experiments. So, how does this information get put to use? Organizations around the globe collect tracking data from their respective sensor networks. This continuous stream of information is then processed to create and update a comprehensive catalog of space objects, which includes active satellites, rocket bodies, and known debris. This catalog allows operators of active satellites, such as those providing your internet or GPS, to perform collision avoidance maneuvers if their spacecraft is projected to come too close to a piece of tracked junk. It is a constant, dynamic process of observation, calculation, and prediction to maintain safety. An interesting detail is that the Joint Space Operations Center, or JSPOC, located at Vandenberg Space Force Base, is a central hub for maintaining the space catalog and issuing warnings. They track hundreds of thousands of objects, but the number of untracked, yet still dangerous millimeter-sized particles is estimated to be in the tens of millions. This highlights the persistent challenge. Understanding the precise orbits of these fragments allows for more efficient orbital planning and helps prevent devastating chain reactions of collisions, a scenario often referred to as the Kessler syndrome, where impacts create more debris, which then causes more impacts. Ultimately, the ability to track space junk across various sizes is not just about identifying potential hazards. It is about preserving access to space for future generations. By meticulously monitoring and cataloging debris, we safeguard our invaluable orbital infrastructure, protect astronauts, and ensure the continued benefits of space technology for everyone on Earth, maintaining a clean and functional environment above us.
Join us at Space Tech Insider, where innovation meets the infinite. Discover the future today.